Okay, everybody, let's go ahead and get started with Chapter 7, Lesson 7.1, Adding and Subtracting Parts of a Whole. So when can you add and subtract parts of a whole? All right, well, so fraction circles, we're going to use fraction circles in this lesson, and color pencils, markers, something just to indicate and to color in the fraction circles. So Miss Clark has the following pie pieces left over from a bake sale. She has 3 pieces left in this pan, and she has 1 piece left in this pan. So she will combine the pieces so that they are in the same dish. How much pie will be on the dish? So we can model the problem using fraction circles. Draw a picture of your model, then write the sum. Sum, remember, means to add. All right, so in the first one, she has 3/6 pieces. The second one, she has 1/6. So the model represents 3/6. This model represents 1/6. So what would happen if we put these together? I would no longer have just 3 pieces in this one. I would have 4. So this is what it would look like after sharing or combining. I guess I should say combining. So 3/6 plus 1/6 is 4/6. So how much pie is on one dish? 4/6. Okay, that's not too difficult. And we could use these fraction circle pieces to show that. So it started with 3/6, or 1/2 of a circle, right? 3/6. And then they took one more from another pie dish and combined it. So now we have 4/6. Okay. And suppose Miss Clark eats 2 pieces of the pie. How much pie will be left on the dish? Model the problem using fraction circles. Draw a picture of your model, then write the difference. Remember, difference means subtraction. So here I see 6 pieces in the pie. Sixths. The pie dish was broken into sixths. And I have 4 pieces here. But apparently she decided she was going to eat 2 of them. So this is how we would show subtracting from a total. So we had 4/6, and then we have to remove 2 of the 6 pieces. So how many does she have left? She has 2 of the 6 pieces left. So 2/6 of the pie is left on the dish. Okay. Page 280. So Kevin says that when you combine 3 pieces of pie, and 1 piece of pie, you have 4 pieces of pie. Explain how Kevin's statement is related to the equation 3/6 plus 1/6 equals 4/6. Well, okay. So we got a couple of things going on here in this problem. First, we know that 3 plus 1 does equal 4. Okay? And we also know that the 3, the 1, and the 4 are the numerators, in the equation 3/6 plus 1/6 equals 4/6. Okay, so 3 plus 1 is 4 because they said 3 pieces plus 1 piece is 4. All right, I'll give them that, yes. And 3, 1, and 4 are the numerators in the equation 3 sixths plus 1 sixth equals 4 sixths. The fractions are actually more specific than 3 plus 1. The fractions in the equation show us the size of the pieces of the pie, whereas 3 plus 1 are whole numbers. And they do not tell the size of the pieces. Okay. So 3 plus 1 are whole numbers. 3 pieces, 1 piece is just telling you those are wholes. Okay. And they don't tell you the size of the pieces. So if you put 3 sixths, though, now I know the size. Okay. Isabel wrote the equation 1/2 plus 1 sixth equals 4 sixths. And Jonah wrote 3 sixths plus 1 sixth equals 4 sixths to represent combining the pie pieces. Explain why both equations are correct. Well, what's another name for 1/2? Or what's another name for 3 sixths? Another name for 3 sixths is 1/2, isn't it? So if 1/2 is the same as 3 sixths, then they are the same equation. Isabel just chose, instead of writing 3 sixths, she wrote 1/2. But they are equivalent. Okay. So 1/2 is equivalent to 3 sixths. So the equations are equivalent. If there's 4 sixths of a pie on a plate, what part of the pie is missing from the plate? Write an equation to justify your answer. Okay, well, the denominator tells me how many total pieces there are in the whole. So if the whole pie was there, I know there'd be 6 pieces. So before we eat anything or before we remove anything from the pie dish, it's 6 out of 6. There's 4 sixths of pie on a plate. So minus 4 sixths, because that's what's on the plate, how much is missing? 6 take away 4 is 2 out of the 6 pieces. So 2 sixths. Now I can also rewrite 2 sixths, right? Because 2 is a factor of 6. So I could say 2 sixths or 2 divided by 2, which would give me 1/3. Okay, so 1/3 of the pie is missing. You can only join or separate parts that refer to the same whole. All right, so that's good to know. Suppose Randy has 1/4 of a round cake and 1/4 of a square cake. Okay, are the holes the same? Is this circle the same as the square? No. No, they aren't the same size. Does the sum 1/4 plus 1/4 equal 2/4 make sense in this situation? While mathematically 1/4 plus 1/4 is 2/4, it doesn't make sense in this situation because I can't take 1/4 of this circle and add it to 1/4 of the square and say that I have 2/4 of a circle or that I have 2/4 of a square. I can't add them. So if we change this situation, instead of having a square, we had another circle that was 1/4, then I can combine those and have 2/4. Or if I change this circle to a square, then I could say 1/4 of the square plus 1/4 of the square equals 2/4, because they're the same thing. They're the same size. All right, number 1, page 281. Use the model to write an equation. Okay. Well, I see that there are a glare, or is a glare on my paper. All right, so there are 5 total pieces in the first circle, and 3 out of the 5 are shaded. I see that 1 out of the 5 pieces in the next circle are shaded, so 1/5. So the circles are the same size, so it makes sense to combine them. So 3 plus 1 is 4/5. And that's what this shows us. 1, 2, 3, 4. 4 out of 5. In number 2, how many parts are shaded? 1, 2 out of 3 triangles. But remember, the circle with the X through it means we're going to subtract that. We're taking it away. So we're going to take away 1/3 of the triangle. Does that make sense to do? Yes, because all these pieces are the same size. So 2/3 take away 1/3 leaves me just one shaded green triangle if we remove that triangle. Okay, so now let's continue. This time we have 1/4 square plus 1/4 square equals 2/4 square. Not hard. I can combine these because they are the same. They represent the same whole. So 1/4 of a whole, 1/4 of a whole, square. All right, number 4. 2, 4, 5/8. Where did I get 5/8 from? Because that's how many are shaded in. 1, 2, 3, 4, 5. Take away. Okay, this represents take away, the circle with the X through it. And they're taking away 3/8. So how many eighths are left? Just 2. 2/8. And actually, I want to go back to number 3. Another name for 2/4 is 1/2. Another name for 2/8, remember we can divide by 2 because they're both even numbers. 2 divided by 2 is 1, and 8 divided by 2 is 4. So 1/4. All right, number 5. 3/4 take away 1/4. All right, so that is what that shows us. 3 shaded 1/4. They're taking away 1/4, and that leaves me 2/4, or 1/2. Okay, number 6. This is 5/6. This is 1/6. They're the same shape, same size, so it makes sense to combine them. If I put this one piece here, I now have 6/6 of a circle. And 6/6 equals 1 whole. Okay, number 7. Sean has 1/5 of a cupcake, 1/5 of a large cake. Are the holes the same? No. Okay, a large cake is not the same as a cupcake, so it's not possible. Does the sum 1/5 plus 1/5 equal 2/5 make sense in this situation? No. If a circle and a square, adding those pieces together doesn't make sense, how could it make sense to add a cupcake, 1/5 of a cupcake, and 1/5 of a large cake? They're not the same size. So you can't do it. So in other words, he doesn't have 2/5 of a cupcake. nor does he have 2/5 of a cake, of a large cake. Okay. Carrie's dance class learned 1/5 of a new dance on Monday and 2/5 of the dance on Tuesday. What fraction of the dance is left for the class to learn on Wednesday? So the dance is the same on both days. They didn't add a different dance. They didn't say 1/5 of this dance and 1/5 of another dance. It's of the same dance. So 1/5 on Monday, 2/5 on Tuesday. So the group has learned 3/5 of the dance. But the question says, what fraction of the dance is left for the class to learn? Well, they've got 3 out of the 5 parts of the dance memorized. So the whole part would be 5 out of 5 parts, right? Well, 5 out of 5 would be one whole dance. They've learned 3/5 of it. So 5 take away 3, 2/5. Great. All right, page 282. All right, sense and nonsense. Samantha and Kim used different models to help find 1/3 and 1/6. Whose model makes sense? Okay, well, it should be apparent which ones doesn't make sense. There's no way I can add these two shapes. They're not the same. So 1/3 of this does not represent 1/3 of this shape. So I can't combine them. 1/3 of this cube, I can combine with 1/6 of this cube. They're the same shape. Okay, the cube is the same shape. All right, so Samantha's model is nonsense. Okay, so there's no way she can combine them because they're different sizes. Okay, but this one we can combine. Okay. And basically this would be 1/2 of the shape if they did that. Okay, 2 pieces equals 1/3 of this. So 1, 2. So if we took these 2 pieces and put them here, I would wind up with 3/6 or half. All right, number 10, draw a model you could use to add 1/4 and 1/2. Okay, so the key here is the pieces have to be the same. The holes have to be the same. So we have 1/4 plus 1/2, which would equal the half is worth 2 pieces, right? 2/4 plus the 1/4. So it would equal 3/4. 1/4 plus 1/2 equals 3/4. And last one. Cindy has 2 jars of paint. One jar is 3/8 full, the other jar is 2/8 full. Use the fractions to write an equation that shows the amount of paint Cindy has. Oh, well, okay. 3/8 in this one, 2/8 in this one, for a total of 3 plus 2 is 5. Because the jars are the same size, I can combine them, 5/8. So boys and girls, that's it for lesson 7.1. Tomorrow, our lesson will be writing fractions as sums. So until then, may the numbers always be in your favor.